will tell you something about Bluetooth Low Energy, or BLE in short. I will tell you some basic theory about how it works in relation to the iOS, and we are going to do a little bit of live coding, so we can practice. I even brought devices, so hopefully you all have your micro USB cables with you. And after that we will do a little bit of a deep dive and actually catch some packets from the air, so you can see how the BLE actually looks like directly on very low level. So what actually is Bluetooth Low Energy? It is a wireless communication standard that is using 2.4 GHz frequency. It's the same as Wi-Fi, and the 2.4 GHz frequency is in so-called ISM band, which is basically open frequency, which anyone can use, except for some minor slices of this range. It is very low power and short range, and it's intended for transmission of small amounts of data. So it's useful for battery powered devices and sensors. You might have seen some IoT stuff like heart monitors or temperature loggers or other fancy BLE stuff, even like remote controlled toys. And since this is pretty widespread standard, it's being used quite a lot, and almost all modern smartphones can talk BLE, which is quite useful because you don't need to mess with wires if you want to control some small things. You don't need to fit these lightning cables to any devices, which is extremely difficult. So it's been in use for quite a long time. It's about 6-7 years when the standard was actually published, and it is not to be confused with something called Bluetooth Classic, because before BLE there was something called Bluetooth Classic, which is similar to some extent communication protocol, but it is intended for something completely different. You may know, for example, Bluetooth headsets or hands-free units, or I don't know, older phones used to be Bluetooth Classic for exchanging data, contacts, and synchronization. But BLE is not compatible with this one. If you want to have a device which can talk Bluetooth Classic and BLE, they need to have two different link layers. Basically, this is the thing that sends stuff on the radio, but the physical layer of the radio is very similar, so you can utilize same hardware actually, but the software stack is very different. The other names for Bluetooth Low Energy are BLE. You can sometimes see Bluetooth Smart or Bluetooth 4.0. So how it works? There are actually two roles that are defined, and these are central and peripheral. Central is usually your iPhone, or something that has a lot of processing power and can handle many connections to peripherals. So it acts as a master, the device that actually initiates the connection. And in client-server view, this is the client. Basically, the thing is asking for data, and it's managing the communication, pairing, and all that stuff. And peripherals are usually the little devices that you are reading data from. For example, this one, which you will get your hands on later. And this works as a server, slave. Basically, it waits for central to talk to it and request any data from it. It can then communicate with the server, with the client or central, and create encrypted connections, and has the data that master or central usually wants to read. So this is a little bit different from, for example, networking. So these terms will be used a lot. So remember, central, this is your iPhone, and peripheral, this is the device you are connecting to. So if you want to connect something, first you need to find it. And how do you find it? BLE devices usually send something that is called advertising packets. They are small amounts of data that announces presence of certain peripheral and tells its capabilities. So basically this little thing will yell around and will scream, I'm here, I'm here, I'm here, connect to me, roughly like 50 times per second. You can stuff 29 bytes of data into advertising packet, which is enough for, I don't know, device name or some service description. I will get to that later. And there are even devices which only work like without connections. Basically, they are spewing data in advertising packets. These are, for example, some simple thermometers or heart rate monitors, and you basically catch the data and process it without actually connecting to the peripheral, which is useful sometimes because if you don't need to handle the connection logic, you can get away with way smaller like microcontroller, and it can last to simple coin cell battery about 2 or 3 years actually, so it's that low power. The advertising is stateless. Peripheral basically shows all around, I'm here, and nothing else happens. So if you want to get, as a peripheral, if you want to get some data to centrals, you will use advertising because actual BLE connections are point to point, and there cannot be like multiple centrals connected to one peripheral. And this is exactly the technology that is used by iBeacons, for example, which is like fancy name for specific format of an advertising packet that Apple has devised. And we can actually catch iBeacons and we can work with them not with core Bluetooth framework, but actually with core location. So hopefully if there is time we can get also to iBeacons, but we'll see how fast we'll go. So right now I will show you how it works. So I have this app that is called Light Blue Explorer. It's basically a Swiss knife for poking into various BLE devices. And I have filtered out the device with the strongest signal right now, because I can enable filter, and you can see that we will discover like quite a lot of devices. There are plenty. So I will filter it again. And this RSSI, this means received signal strength indication, basically how powerful the signal is, and from that you can actually calculate how far in ideal conditions the device that is advertising is. So with 3 or more devices you can actually calculate indoor location using this signal strength. And there are some indoor location tracking frameworks that already does this, and it's quite useful and it works surprisingly well.
How accurate is it?
Well, around half meter maybe in indoor conditions if there are not so many metal objects around, because the signal bounces around and it can sometimes mess with the results. But in ideal conditions you can get to half meter accuracy. So right now I can see ESP blinking and some magic number, which is this device I've brought, and I'm going to connect to it. So click on it, and it interrogated the device, discovered what actually the device is offering, and we have a lot of weird numbers here. So I will click show and I will check the advertisement data. So there are three fields. In the advertisement packet, there is indication if you can actually connect to the device. Because if you have device that broadcasts only advertising packets, you cannot connect to it. So this is indicated in the advertising packet. But I can connect to it, so that's good. And I have a local name of the device here, which is the same as shown here in the app. But it's actually taken from the advertising packet. And then I have service UID here, which is some like weird number. I'll get to that later. So I have two services in my device, and first one or the second one is pretty straightforward. This is device information service. So the device is telling me what it actually is. So I can see manufacturer name, model number, and serial number. So these are only like static strings that can be used for actually identifying the device. And they should be included in every BLE device so that you know what you are actually talking to. Then we have some custom services with weird numbers. So you can check that there are several properties, read, write, notify. I will get to that later. So if I write a value there, I'll put there 1. See that it blinks. So I can actually control and transmit data to the device with this app. This is like generic app. It shows you everything there is to show, but it's very useful if you are debugging the device and trying to like get hold of what the device actually offers. But same thing can be achieved by using core Bluetooth in our own app, which we will get later. So right now I'm going to disconnect from the device and now we'll continue with presentation. So as I was mentioning, Light Blue Explorer, you have a link there which you can download, and you can poke around in your BLE devices if you have any. So, more details, how it actually works. The BLE is very like layered protocol. There are a lot of sub-protocols stacked on top of each other. So the first one we will encounter is something called generic access profile, which basically tells us or specifies how are the connections supposed to work, how sending advertising packets is actually working. You can set low-level connection parameters there, and unfortunately you cannot mess with this generic access profile directly on iOS or macOS, although it would be extremely useful sometimes because there are several parameters that influence actual behavior of the connection. For example, how fast the device is sending the data, how big packets you can actually send, but this has to be specified in the device, and iOS in certain situations is adjusting these parameters. So if the device isn't prepared to handle those changes, it usually ends in broken communication. So we have a little diagram there. We have first state that is standby, and then we are seeing differentiation in roles. This advertiser is something that is sending advertising packets, so in our case peripheral, and then we have central, which scans the packets, then initiates the connection and becomes master, and the peripheral to which we are connecting becomes slave. It's way more complicated underneath, but usually this is handled by common protocol stacks. So if you will be writing an actual implementation of BLE or using the implementation of CB peripheral that is on the iPhone or Mac OS, then you will have all this stuff handled for you. More interesting is GATT, Generic Attribute Profile, and this actually specifies how the data are laid out in the device and how are they handled. So this service or this protocol handles service discovery so that you can get to know what the device actually can do. It handles security, so no one can listen to your conversation, and it handles authentication, so only you can connect to the device. How it works? We have something that is called service, which is basically a collection of characteristics. And characteristic is something that contains data and information about how to work with those data. So you can imagine it as a very simple file system. Each service and characteristic is identified by UUID, some universal identifiers, which can be random, and also there are sets of well-defined identifiers that you can use for, I don't know, the device information services, or there are heart rate monitoring services. There is around, I don't know, 45 or 50 services that are well specified, and usually the apps for poking around in BLE devices like light blue will render them as they are supposed to be rendered. And also iOS core Bluetooth is handling those names, so it is converting those IDs to something humanly readable. So each characteristic has value. You can read or write the value, and you can also have something that is called notify. I'll get to that later. And each characteristic also has descriptor, and in this descriptor you can specify what the characteristic is actually called, what the data it represents, and there are some extended properties related to authorization. So the value of characteristic can be read, you can write it with or without response. Basically, if you write without response, you send the data and you don't care what the result is. You just send them over and over again, which is useful for something that changes quickly. And if you want to be sure that the write actually succeeded, you will use write with response, which will confirm that the data were actually written to the device. And then we have notify, which is something between like read and write, because you can turn notify on for certain characteristics, and if the characteristic changes for any reason, like temperature increases or user pushes the button or something like this, the device will tell you about this change without actually asking for it. So this is also a pretty nice way how to store save energy, because the device can be in sleep mode, and if something happens, the device wakes up and sends a notification to Central, and Central can process it. All the values in characteristics are actually sequences of bytes, which can be arbitrary. It depends on what the characteristic is used for, and well-defined characteristics have like specifications about what the data actually means. But if you invent your own characteristic, or you will encounter the device that has something different, it will be like unspecified. So you will have to have your own documentation for what the value actually means. And the characteristic values can be secured. This means that if you are trying to read the characteristic, the device can initiate pairing, because after you pair with the device, the connection is encrypted, so no one can read it. And some characteristics are marked as secure, so you cannot read them without this process. So, the BLE security. There are two terms that you may encounter, and this is pairing and bonding. Basically, pairing is the process of exchanging encryption keys, and there are several ways how to do pairing, more or less securely. It depends heavily on how the device is built and usually how expensive it is. And then there is bonding. After you are paired and the tokens or the encryption keys has been exchanged, the device, iPhone and also the BLE device, will store those keys so that you don't need to pair again when you connect to the device. And iOS actually does both, and it does it automatically. So you actually have no control over pairing or bonding if the device initiates the pairing request, or you touch any characteristic that is protected, that is secured. The process of pairing will happen automatically, and you don't even get any notification that it was successfully completed. The alert, the controller will just pop up, and the user will click allow or will enter some PIN. So there are 4 pairing modes. First one is called just works, which is basically super unsecure, but it works because there is no randomization of the keys. The key for initiating the encrypted session is always 0. So this might look a little bit weird, but imagine that you have a device that has no keyboard, it has only a status LED or something, and you have no way how to input something there. So you just use this first mode of pairing, and it's actually sometimes it's tied, for example, to push of a button. You can pair with the device only after you push a button on it, so no one else can pair with it without your knowledge. So this is the first mode. Then you probably encountered this. The second mode is pin entry, and the peripheral will have some pin, some number, 4 to 6 digits stored into it, and if you attempt to pair with it, you need to enter this pin, and only if you enter the pin you will be successfully paired, and the pin is basically the seed for the keys. Then you have number comparison. You can see this authentication, for example, in Apple keyboards. Basically, both devices show you some number, and the user is supposed to indicate that the numbers are correct on both sides. So with keyboard, it's quite easy because the computer displays the window with pin, and you type it into the keyboard, and then it's paired. So this is also useful. And then there is out of band pairing mode, and this means that the initial key for encryption is transferred via other means, for example NFC, or the user types it manually. There are way more ways how to actually do the out of band authorization, and this is the most secure way, but also requires the most expensive hardware, because you need to have some way how to get the number into the peripheral. So, a lot of talk. Now we'll check how the data that are actually flying over the air looking like. So I have this thingy, which is BLE sniffer, and this can capture and analyze all the BLE traffic that is flying around. So let's say I will fire up my trusted Wireshark, and we'll check how the device actually talks to us. Hopefully we'll be able to see it. Let's mistakenly want to start, but we're here and we have this thingy. So, right now there are a lot of advertising packets from various devices flying around. One is from my ESP Blinky, you can see the name here. So, right now we have about 10,000 packets, which is quite a lot. So right now I'm going to filter the communication and I'm going to display only the advertising data from my device. So if I fire up light blue, I think there can be, there are some scanning requests, hopefully there will be also a scanning response. So how the advertising packet actually looks like. We have some headers, address, and then we have advertising data. And in this data, we actually have only like 18 bytes, and this is the device name. That's all. So very simple, very small amount of data that is no longer than 40 bytes. So it's transferred very quickly. And right now, I'm going to connect to my ESP Blinky. I will select it here, so I can filter it. So before I connect to it, so once again, so right now we have something that is called scan request, which is coming from my iPhone, and this tells the advertising device to tell us more about itself. So following this request, there is a scan response, which actually contains different data than the advertising packet. And there we have a service class UID, and this tells us that the device has specific service to which we are going to connect later. This is quite important, and we'll use this in further operations with our device. And right now, we have something more interesting. So, there is connection request from the master. They are exchanging versions, feature requests, some responses, and they are agreeing on MTU. MTU, this is like maximum transfer unit, basically the longest packet that you can receive or send. So if you have a device that sends quite a lot of data, the MTUs can be up to 2 kilobytes, I think. But usually it's around 200 bytes because the longer packets drain battery more, so because the radio has to be on for a longer time. And right now, in these packets, we are seeing that the master is querying the device and asking it about the services that it actually has. So there are requests for primary services, for attributes, and there is some error. Oh, I know, why is that? Because the master is expecting some service that is not there, so it just errors out. And right now, information. These are the responses for the scans of the BLE services. And those handles, these are basically numbers of the characteristics which are used for actual transmission, because the UIDs are used only when discovering the services, and when you have already your services discovered, you only use the handles. But iOS does this for you, so you don't need to mess with it. So right now, for example, I will to read something. So I've sent read request and received a response with certain value, a 1, which you can see here. So the value was actually transferred. And right now I will enable listening for notifications, and I will create a notification here by pressing button. So you can see the numbers are actually changing, and there are value notification packets. So as I was mentioning, it is quite layered, so there are like three protocols actually in play, and the last one is this attribute protocol for this service and UID with this specific value. So this is how BLE communication actually looks on wire. Any questions so far?
Can I see there not Bluetooth low energies packets in that software?
Sorry, I didn't get the question.
You had some advertisement from Bluetooth low energy on that software.
Okay, yeah, I have. These are packets that are flying around.
What is the name of the software?
This is Wireshark.
Wireshark.
Wireshark, yes.
And can I see there no Bluetooth low energy advertisement?
Well, there is BLE advertising, but this software is now configured in a way that it captures only like BLE packets. So advertising packets and the communication with a selected device that you are connected to. So right now I'm going to stop the capture and we'll move to presentation. There is not much more in the presentation, so don't worry. So BLE in iOS, how this is handled. We have core Bluetooth framework, which is present both on iOS and macOS. Core Bluetooth can configure Bluetooth hardware in these devices to act as central or peripheral. So you can actually simulate some devices if you don't have actual physical device, or you can use central to connect to various devices and get data from it. The API is asynchronous, quite a lot, which sometimes can be useful, sometimes not. It can run in the background actually, so you can stay connected when the app is in background, and the system will keep your app running and it will send notifications to it, or it will wake up the application. It's quite a high level of abstraction, because you only get quite a narrow peek into all the powerful stuff that BLE has to offer. On Android, it's a little bit better in terms of like low-level hardware interaction, but usually you don't need that. I've encountered very few cases when this was needed, and it can always be like, done on the device, so it can talk the same flavor of BLE that iOS is actually expecting. Because iOS is very picky about how the device responds and what to expect there. And if it is not there, you will see a lot of strange bugs with core Bluetooth because the device actually doesn't talk in a way that the iOS or macOS is expecting it to. So, you've all seen this. Now you will get one, and you will return it afterwards. So, this is the business end. You will stuff USB cable there. Here we have the button. It's labeled boot. Don't worry, you can press it. It won't like boot the device. And the button works in a way that you can actually turn the blinking LED, the blue one, on or off by pressing it. Press it, yeah, it stopped blinking. Now it can start blinking. And you can control this behavior also from VLE. So that's how we're going to test it. We have power LED, which is red, which is here, and the blinky LED, which is blue. And we have the scribbled important number. Because the devices are all the same, they need this number so that you can distinguish them from each other. So each one will get a device with a different number, and if you are implementing something, please do not connect to your colleague's device, connect to your own. So try to remember the number or look at it each time when you are connecting. So we have a demo code. Download it from this GitHub repository, and there is a branch, WIP, work in progress. To this branch, please switch, and we'll start from here. So after you've downloaded the repository, come get your device. Do not remove the foam from it. It works with the foam too, and you don't scratch the table. Okay, don't plug it yet, please. So, 6 more devices left. Who doesn't have a device? Who doesn't have a device? Put your hands up. Okay.
But we don't have cables.
I have one spare cable.
It's not enough. We have one spare cable.
Okay, not enough cables, I guess. So one last device. Who doesn't have device? Who wants device? Okay, so now we'll get to some live coding, finally. So if you have the BLE iOS demo, then please switch to work in progress branch. And you can code with me if you want, and if you are lazy, then you can switch to master and you will have it finished. But I really recommend to code with me, because you will actually learn how to write this stuff. Can you see it also from the back?
Yes.
Really? Okay, I will make it bigger. Okay, so we will write a simple app that can discover the device, can read its services characteristics, and it will be able to listen for notification, and it will even run in background. So I've prepared some classes, and we are going to complete the rest, well, the important bits, because I guess you all know how to write table views, so I've prepared it here. So right now we'll start with a class that is called BT Manager. So please go to this class, and you can see that it's importing core Bluetooth, and it has some delegate protocol. We'll use this later. And this class extends from NS object, unfortunately, because the CB Central Manager delegate, which we are going to use, is Objective-C stuff, so we'll need this NS object stuff here. So, first thing we are going to implement is creating the CB Central Manager. I will name it simply Manager, so more managers. And we will need our delegate. So this is optional. So we will write password for Wi-Fi. STR hier myslím, alebo okay. So we will create an instance of CB Central Manager. You can have more instances of this CB Central Manager, but I really recommend to have only one, because otherwise you have no guarantee in which order the commands are actually sent to the peripheral. So we will need a delegate for this manager, but right now we are going to put nil there. And you can specify dispatch queue on which the delegate methods will be invoked on. If you put there nil, it will deliver the events on main queue. Then we have options, and options can be, or there is like one useful option, which is CB Central Manager scan option allow duplicates key simple, and we'll put true here. And this option means that the manager will deliver us events when the peripheral which has been discovered before has been discovered again, which is useful if you want to decide if the peripheral is no longer in range. So right now we've created our manager. We'll call super because we are in NS object subclass. And then we can set the delegate, because before that we didn't have self, so we needed to initialize all properties. Right now I can uncomment this extension to BT Manager, and it will implement the CB Central Manager delegate. So there will be our events. And who is complaining? So we are going to add this method. Central Manager did update state. So why is this method here? Because as with all Apple stuff, you need to get authorization before you use Bluetooth, or the Bluetooth can be turned off, it can be disabled. The device doesn't even need to have a Bluetooth. So you will get a notification, or you will get invocation of this method when the state of central manager actually changes. So I will just print it right now, so we can see what the state actually is. And in BT Utils class, I've added this extension to CB Manager state, and it extends custom string convertible, so you will actually get a string value of it because it's integer based enum, and you cannot see more of this when you don't have this extension. So right now I will try to run it. I'll see what it actually prints here. So you can see that we got state powered on, which is good because the Bluetooth is enabled and all is perfect. And only when the state is powered on, you are allowed to actually call other methods of the CB Central Manager. If the state is not powered on, it will complain heavily. So let's see how it looks on the device. If I disable Bluetooth, you see that state powered off popped here immediately. If I enable the Bluetooth again, we'll have power on. So yeah, this works pretty well. One more thing, if the Bluetooth is powered off, you need to invalidate all existing connections and CB peripheral and central managed objects that you might have. Otherwise, they are not going to work after the state is toggled back to power on, which is quite important. So right now we are going to handle this somehow. So there are two states which are transient. This means that they will just show up and then they will disappear. This is unknown and resetting. So you handle them basically by not handling them. Then we have the state which we are looking for. This is powered on state. And I will add a to-do here so far. Start scanning. And then we have all other states, powered off, forbidden, etc., etc. And here we have to stop scanning for new devices. So we have those to-dos. Now we are going to implement the scanning. So we'll add this property, which will be false by default, and we'll want did set. So if the value hasn't changed, we can return safely because nothing happened. I'll just put some debug log here. Scan state set to scanning like this, so we know what is happening. And if the scanning has changed to true, we will scan for peripherals. There is with services, this is weird, I will just put nil there. And I will also put nil to options. It's not important yet. And if the scanning is set to false, I will stop scanning, which is very simple, I guess. So by setting the property, you can actually control the invocation of these methods. You should be careful about from which queue you actually call those methods, and it should be the same queue as the one you specified when constructing the manager. If you use different queues for this, you might run into some bugs with concurrency. So for sake of simplicity, I will be like redispatching the calls to main queue, but in production app I highly recommend to use either dedicated queue or a main queue for this. So we have this scanning property done, and now we can start scanning when powered on and stop scanning when any other state. So we've started scanning, and now there are results. And the results are handled in yes, Central Manager did discover peripheral method. The signature is quite crazy, but you will see that there are all things you need. So for starters, I will just print the peripheral we got. Now I'm going to run it. So you can see quite a lot of peripherals here, quite a lot of them. So we have state powered on, scan state set to true, and now peripherals are starting to pour in, and all are disconnected. Obviously, some have name, some don't have name, and notice that all of them have identifier. This identifier doesn't change with the device, but it changes when you try scanning the device from different iPhone. So it's only like local, so you shouldn't send it to network. You use it only for identifying the specific peripheral. So careful with that. So we have bunch of weird devices. So how we are going to distinguish which device is ours? We can either filter by name. So we have some ESP Blinky here, we have some Philips, and we have some ESP Blinkies. So I can try to filter by name. So I will print the discovered peripheral only if it has prefix, and I need to unwrap it. And if the peripheral doesn't have a name, it won't print simply. So right now we have few ESP Blinkies around, and that is all. Which is kind of useful, but well, you are discovering all the devices that are around, you are draining the battery needlessly, and there is a better way how to actually do this kind of discovery. So you can notice that within scan for peripheral methods there are services. So we can actually specify which services we are looking for, and the core Bluetooth will filter the scan results for us. And if you use this, if you put some services there, it will even allow you to continue scanning in the background. If you don't put any services there, it will kill the scanning process while in background. But if you put service UIDs here, you can scan for nearby devices while the app is backgrounded, which is quite useful. So, I have a class that is, or struct that is named BTU UIDs, and there is a Blink service UID. If I click through it, you can see that this is the weird number, the same weird number that you have seen in the light blue Explorer. This is basically the identifier of our service, the service we are looking for. So, I've put the service ID there, and now I can disable the name prefix, and I can run it, and you'll see that I will only get the blinkies if I run it again, because they are advertising this specific service. And if you are using this service, the discovery is faster, it uses less energy, and you can run it in background, so remember that.
Sorry to interrupt. This is the time for a break, so that everyone can switch their legs.
Okay, so break, don't break your leg. Jo, ale ta síla signálu je něco kolem třeba minus 90, minus 80, ta komunikace nebude spolehlivá, to vypadá. Jo, že ten advertising paket prostě jede projde.
A může takhle prosvištíte, které jde všechny iPhone v okolí?
Všechny iPhony. Jo, a tady je to vlastně,
jasně, no,
jsou to nějaké různé ráčky a všechny tady tyhle věci vysíláme.
A to, že to jde na 24 GHz, to znamená, že se...
Já ještě zkusím sehnat sám.
Má někdy z kanálu.
Je to vedle Wi-Fi a Wi-Fi je dokonce uspůsobená tak, aby se nebyla s tím DLčkem.
Jasně, a na frekvenci to jde nějakým jiným kanálu trochu.
Oni mají malinko posunuté ty přikryvy, jakože tam jsou Wi-Fi na frekvenční hloubě někde po 15 takže ty frekvence jsou podobné, ale jako ne úplně
Vy ty videočky, když se takhle přinesu jako silný vysílač, jestli to tady všechno jako zahluší a nebo...
Ne, protože Bluetooth má něco, čemu se říká frekvence holdingu. Při té komunikaci mění frekvenci.
Poslouchá nebo prostě mění, no?
Mění předefinováno klíče. Jo, takže třeba advertising vysílá na kanálu 37, 38, 39, to jsou advertising kanály, které se s každým advertising paketem mění. A potom ta komunikace, já myslím, že byla prostě 40 kanálů, tak to každý paket je, pojďme se
Jasně.
Jo, takže se to takhle přeskakuje, aby právě to nerušilo všechny, a naopak, aby tím nebyla, aby to nebylo rušeno.
Jasně, takže prostě chvilku...
To nakonec jsme viděli.
Já už tam budu. Na většinu ne, utekl jsem po 10 minutách. Ne, možná po hodině. Po hodině jsem ten mohl.
Dává to smysl?
Jako naše obličeje.
Všichni vypadají tak jako zombie.
Na masku je
Jo, před takovým workshopu, tam je jakoby workshop, tam bude a Vodafone nabízí stejné device, jako IoT, ale different device dělají jako chytrou síť. České systémy, pokud na celé České republiky, měli takový device 3x více, naštěstí ne. Můžu používat data čistou síť, to není test, které Vodafone je to zvláštní IoT věci, to je taky zajímavý. Protože teď jsou měsíční stavy kliniky, nebo nějak tam přihlížíme to malé SIM karta a jinak na to opravdu policie tam stojí se to, že má každý business a tam je já to ale tam je takové velmi zajímavé věc, co ty device, to je vodou, a 20 metrů tam, kde ty nefungují obyčejně. Jako tam byla už jsme si dělali. Co zabudovali tu síť a už 6 měsíců. Byl ještě na nějakým workshop, kde přednášky.
Můžeme tam být.
Děláme takovou jakoby mesh síť a через ty device zahrávali není tam moc.
Okay, so are you ready? Can we start? Finish chewing your sandwiches and you can get back to Xcode. So we filtered the devices that are around using the service ID. Sorry. And now we are going to store the found or discovered peripherals to be used later. So I will add a new property to our manager, and this property will be private, and it will be a dictionary called scene devices, and it will be UID and BT device, and BT device is other class that I've prepared, and this will abstract all the stuff that we need to do with the actual discovered device. And at start, this scene devices dictionary will be empty. So, when we discover our device, we will simply stuff it into the scene devices dictionary. Scene devices, and we'll use peripheral.identifier, which is the unique identifier that iOS is providing to us. So this is quite useful. So if we don't have the device, we will edit peripheral identifier BT device, and we are going to put our peripheral there, and also our CB Central Manager, because there are some operations which require it. So right now we have the BT device, and we are going to create the initializer for it. So we'll switch to BT device class, and we'll store a manager, and peripheral. So it is again NS object because we are going to implement delegate. And we will also set delegate to self, so that the peripheral can talk back to us. Okay. What are we missing? Oh, the override isn't supposed to be there. Okay. Like this. So we have our BT device. We have the values stored. And yeah, scene device is let, so it needs to be var. So fix it. Now we can change the collection. And I will just move the print statement to this branch. And I will also include the RSSI value, which is basically a signal strength that the device has. You can use it for example, sorting or connecting to the device that is closest or has the strongest signal. And if we see the device again, we're just going to print it, but you can use this when for example, you are measuring how long the device is advertising, or if the device got out of range. If you don't see it for a while, then you can safely assume that it got out of range and you can remove it from the list of seen devices, which we are not going to do currently, but we will just print it so that we know that it happened. So right now, we've populated the seen devices dictionary with all the devices that we have seen, obviously. So, now we will export this so that the rest of the code is able to utilize it. So, seen devices, use, and this is some collection, weird collection. So we are going to create array from this. So this is like a public property which we are going to use for querying BT Manager about the devices it has actually discovered. So try to run it and see what happens. Works exactly the same way, but right now we have the RSSI, so my Blinky, which has this number, has the strongest signal because it just lies next to my phone, and there are others with signal strength of minus 79, minus 88, minus 85, which are in the back of the room somewhere. So this is quite distinctive. By the way, now you can connect your Blinkies, and please be careful when putting the cable there because the connectors might be flimsy, so don't over push it so you don't break the connector, please. And it should light up the power LED, and it should start sending the discover packets. And if you have a driver for this device, you can actually see how it communicates with the PC. So I'm going to increase the font size here, and I will show you. I will not show you because for some reason it's not there. Okay, I don't see the list of my ports, so I can't show you, unfortunately. But it has a USB to serial converter, so if you are able to open a serial port and read data from it, you can actually see what the device is telling you about what connected and what is happening. But let's get back to Xcode. We have the devices property on BT Manager. So right now we are going to switch to nearby devices view controller, and there is quite a lot of code that is commented out. So right now I'm going to uncomment all the things in extension. BT Manager Delegate extension on line 64. These are lines 66 and 71, which basically assigns devices from manager to this view controller. And yeah, this will be enough for now because we also need to implement some delegate methods. So right now we'll go back to our central manager did update state, and we will clean the scene devices when there is different state than our own. If someone turns off the Bluetooth or disables it, we should clean the list of devices, and also we should call our delegate method on line 63, so that the code knows that the change in state actually happened. And also we'll add another delegate invocation to discover, and I will create a variable for that. This. So now we'll be sending the same device into the discover method. So we have this, and now the manager communicates with its delegate. And right now we are going to switch to BT device, and we are going to implement a few properties there, so we can actually see in the app how the device is doing. So first we will implement a name property, which will simply forward name from the peripheral, and there is some optional, so we need to provide default value, and then we will add a detail property, which in this case will return its identifier description, basically string value of the identifier. So after you have these two properties, switch back to nearby devices view controller, and we'll set a delegate to the manager on line 35. And then we will provide some values into the cell for table view. So this should be right about enough, and now we are going to run it. And we can see a lot of nearby devices, a lot of blinkies here. Okay. So right now we've discovered the devices and we're presenting them in table view in a way that is quite reusable. So there is one more thing. We'll display a state of the manager and whether it is scanning. To do this, we need to add another property into BT manager. So this will be state. CB manager state, sorry. Like this. And right now it should compile. Probably will succeed. Thank you, Xcode. So we have nearby devices, and on the bottom we have the state of the manager and if it is scanning. So if I'm going to disable Bluetooth, you can see that we've cleared the list of devices, the state is powered off, and the scan is false. If I enable Bluetooth again, it will again discover all the devices that are in the vicinity. So this is our nearby devices view controller, and I guess Now let's switch back to the BT manager. Now we're going to handle a connection to the device. So if we connect to it, we can actually check what its characteristics are and its services. So we have two delegate methods that we need to implement here, or three actually. Well, we start with two. Central manager did connect, which is basically telling us that the connection to certain peripheral actually succeeded. So right now, I'm just going to dump it, and I will look up this peripheral in our scene devices. So peripheral identifier, and this is optional, and I will inform the peripheral about the status of the connection. So I will create another method in BT device. So let's switch to BT device now, and I will put these methods into extension. No parameters, no return type. Okay, so we have a connected callback function, and we are also going to need actual connect function, which will simply ask the CB central manager to connect without any options. So we have a BT device, we will call connect on it. It will try to connect, and after it is connected, it will call our connected callback function. We can do the same with disconnect, and this is named quite weird, cancel peripheral connection. The thing is that connections in BLE are not, for example, similar to network connections, because unless you explicitly cancel it or the connection errors out, it is still persistent. So it's not that you like send a request and it disconnects. You need to explicitly disconnect it, or the peripheral needs to disconnect you. Otherwise, you will be still connected. And if you are connected to any peripheral, it will usually stop advertising. So no other centrals can connect to it because the peripheral doesn't support it. So be careful about disconnecting your peripherals, otherwise you may find out that you cannot discover them afterwards. And I will also put disconnected callback function here. And there is another method of the delegate. Central manager did disconnect peripheral, which is called obviously when the peripheral is disconnected. So I will just dump it, and notice that there is an error object here. So there can be like multiple causes of disconnection. For example, you walk away with the peripheral, so the connection breaks, or it times out for some reason. But if you disconnect cleanly, the error object will be nil. I'm just dumping it here, and I will do the same callback. So disconnect callback. Just pinging those back to the device so we can handle the connection and disconnection logic in one place. So right now I'm going to switch back into nearby devices, and I will uncomment the last method that is here, that actually initiates the connection. And yeah, needs also to uncomment this thing. So there will be actual device property in device VC. So right now I will be able to actually connect to my blinking. I will have to find it in the list. It's here, 1880 46. So right now we are actually connected to our peripheral, and if I pull back, here, we can see that it is not disconnecting actually, because we forgot this method here. So when we destroy the device view controller, we are supposed to disconnect from the device so that we don't block it from other users. So right now I'm going to start the app again, and now you should see the disconnected callback too. If you terminate the app, all the connections that your app has made to any peripherals will be terminated too. So this is okay. So right now you can see that I've actually connected to the peripheral. And if I go back, you can see that there is a clean disconnect. So I've disconnected from my peripheral without any errors. So now let's implement some more methods in BT device. We'll start with the delegate, which I've prepared here. There is a BT device delegate, and I will create a delegate property, BT device delegate, which is optional. Right now we are going to make few calls from the delegate. So connected callback, delegate, device connected. Device disconnected, like this, so that the code that is actually handling the BT device knows that something has happened. So right now we've handled the connection, and now it's time to actually discover what the device can do and start sending data to its characteristics. So I will call the discover services method from the peripheral, and right now I'm going to call it with nil, so it's going to discover all available services that are on the device. And for that I also need CB peripheral delegate, and this will tell me the discovered services. So peripheral did the discover services. After this method is called, you will either have error or you will have some services that are present on the device. So right now I'm just going to pretty print all the services because we have a services property in our peripheral. So simple for each should be good. And I will just print the discovered peripheral and that's it. And then we are going to do more stuff for that. So let's see how it goes. Right now I again discovered all the devices. I have to find my Blinky. Where is it? Here it is. And you see that we actually have two services that are marked as primary, and we have a device information service and a service with this weird UID, which is our Blinky service. That is good. So with that, we are going to discover further. So for each service that we have, we'll call a discover characteristics method. So nil, and for service that we have just found out. And there is also another delegate method that discover characteristics. Oh, that's that one, sorry. Peripheral did discover characteristics for service. That's the correct one. So again, I'm going to service characteristics for each, and I'm going to print the discovered characteristic, then add some new line. So if I run it again, we should have all the services and characteristics discovered, which is good. That's basically what you need each time when you interact with the device. So you see that we are first discovering this service and it has two characteristics. And then the second service, there is a manufacturer name, model number, and serial number. So this is basically very similar to what we have seen in the light blue Explorer. And we can work with that further. So to actually work with any characteristic, we need to store the characteristic, and then we will be able to write any values to it, read from it, and also enable notify. So let's start with implementing new property. This property will be private again, it will be var, and I'll name it print var. It will be type of CB characteristic. So we can actually store our characteristics like this and use them later. So in the discovery, I'll put if here, and if the we have defined previously, then we are going to store it. And also we can schedule this for reading. So if we find the characteristic, we store it and we call read value for a particular characteristic. So the value will be read and afterwards it will tell us what the value is. And for the values we need another delegate method. And this is did update value for characteristic. Oh, no, didn't write it update. Yes, this is the correct one. Peripheral did update value for characteristic. And right now we are going to parse some data from the characteristic. So first we are going to check if the UID of the characteristic is actually the one that we are expecting, and if so, we will try to read its data or its value. And this is specified as an optional data. So I've prepared a simple method that's actually going to parse the data as Boolean. How it works, you can see it in BT utils. There's an extension on data. So basically I'm checking if the data is exactly 1 byte long, and if not, it's something different. So I'm going to return nil. And if the first byte is not equal to 0, basically non-zero value, I will return true, otherwise I will return false. That's very simple. 0 means it's off, any other value means it's on. So I will return back to the device. And I forgot print. Updated value. So now we have our Boolean. So what to do with that? Just shove it to delegate. Device blink changed. On. Okay. Now we should probably store this value for ourselves, so the client or the client code, the view controllers, can read it. So for that, I will add another property, but I want to be for this property to be private. So this, and it will be false start. So now I can assign this value, and it can be read later. And I will also, when discovering characteristics for the service, I will also enable notification for this characteristic. So any change in the notification, in the value, is reported, and I can forward it to UI so that it can actually change how the UI looks. So now I'm going to run it again. Hopefully it's going to work. So bunch of blinkies. I will connect my. Where are you? Here. So I have have discovered characteristics, and you see that there is updated value. So there are some data, but right now we can't see them. But if I press the button, you can see that it actually updated the value. It's down there. So the notify works pretty well, and it's quite simple to actually enable notifications. So right now we are going to add another property, and this will be a public blink property, and we'll have a getter that will simply return our private one. There will be more fun with actually writing to the peripheral, but right now let's just read it. I will switch to device VC, and I will start uncommenting things. So first we'll set delegate, then we'll update the status of the switch if the device is actually blinking. And we can also have disconnect. Probably this not yet. Okay, so it's good. So now let's run it, and I will show you how it actually looks. So here's my blinky. Right now, oh I see, I forgot the delegate call, because when you actually connect to the device and before you have discovered the services and characteristics, you are in kind of a dead zone, because you cannot do anything with the device and you are only like connected. So the view controller here handles it as some like probing state or discovering state, in which all the controls are disabled because we don't have the correct characteristics to read from yet. So I need to return to BT device, and after I discover the characteristics, I will call the delegate, and I will tell that we are ready. Right now, if I run it, and where's my bit? Here. You can see that it actually switched to ready, and when I push the button on my blinky, you can see that the switch actually toggled. So, yay, success. And the rest will be quite simple. If we toggle the switch back, here, it doesn't do anything yet. So we need to implement a setter for the change of the switch if you write to blink, so that it actually toggles the LED. So we'll have setter, and because we do not want to overload the device with repeated values, I need to guard that the values are actually different. So I'm going to store it like this. Because the characteristic is optional, I need to unwrap it. And now I will write value for characteristic. So how do you convert Boolean to data? It's weird, but So you are using a data constructor with array of bytes, and you are supplying either 1 or 0 depending on the blink value. And we are writing to our blink characteristic, and because we want to be sure, we'll specify with response write type. So right now, we can run it, and hopefully you will see that everything works as expected. Here is our blinky. It's ready, it's blinking, you can see. And if I tap it, yeah, it stopped. It works both ways. So if I press the button, this is the correct button. So that's why, this is how you can implement like simple state switch with notification, so that the device will actually tell you when it changed its state. So we have a second characteristic in our Blinky service, and it actually controls the speed of the blinking. So we will uncomment a few lines here, and we are going to write some more code, and you should be able to control the speed at which the light actually blinks. So let's call it speed, and it will have getter, another internal property. So private var speed, it's an arbitrary number. So right now we have getter, and we also need a characteristic. So speed characteristic, and when we are discovering characteristics, we will again test the UIDs. Blink speed. So speed characteristic, we assign it, and we are going to read the value as we discover it. Like this. So right now we have another value. So we are going to test the UID, speed characteristic UID, and if those IDs are matching, then we are going to parse the value. And I've prepared another method, it's called parseInt. And it's again in BTUtils. Basically it returns the first byte, and it returns it as 1 byte unsigned integer. So the values can range from 0 to 155. So we have our value, and we need to set it to our property, and also notify delegate that we've changed our speed. So that's without warnings, and because you cannot set the speed on the device, this characteristic doesn't have a notify ability. So if you call notify on the blink speed characteristic, it will actually fail because the device doesn't support notifying this characteristic. So setting the speed. again, we are going to guard it for changes. We are going to set it into our internal property, and then we write it back into the characteristic if we have one. So we are creating new data object with bytes, and the byte will just be inversion of the speed. We'll write it to this characteristic, and we are going to wait for the response. So that's about it. Let's run it, and behold. So we have a ready state. So if I toggle blinking, see it blinks. If I change the speed, it's blinking way faster. If I toggle it like this, it's blinking way slower. So I can actually influence like other behavior via those characteristics. And this is only like available from Bluetooth. It doesn't have any controller which you can use to set the blinking speed on the device directly. So there is no need for notification. And each characteristic also has something that is called properties. And by inspecting this properties value, you can actually find out if the characteristic supports reading, writing, or notifying. If I click to see the definition, properties, you can see broadcast, read, write without response, write, notify, indicate, authenticate, sign, write. These are like another properties for characteristics, but most common that you are going to encounter are read, write, and notify. So there can be some secured properties, for example, some secured characteristics you can only write if you are paired with the device, or you need to be encrypted to have notifies. So you can do a lot of interesting stuff with that. Unfortunately, we don't have enough time to go through all of these options. So, and the last thing that we are going to do today is reading serial number from the device. So it's in a different service. So I'm going to put another if into the discover characteristics. And we have info serial. So I'm just going to read the value of this one, and I won't be storing it anywhere for now, so that you can see how other types of data are handled. So we have a read value for info serial, and here we handle it, characteristic UID as info serial. Then we are going to store or unwrap the data data can actually do this for ourselves. String data and encoding UTF dates. Forgot the property, so right now we are going to add another property. And this one will have private setter. So that we can read the serial number later. And when we thread this, we need to also notify the serial. I need to unwrap it, but because I just created it, I can. Because this data thing can return optional, I think. So right now we have this new value of the serial. So right now I'm going to comment this last line, just check if there are any other commented out lines. No, there are not. So when we run it, we have a lot of blinkies again. Here's mine, and you can see that I've actually read the serial number, which is 188046, and well, this is all the useful data basically you can get from our Blinky. As mentioned before, you can toggle the speed, it works with notifications. So maybe one last thing, I will show you that it actually can work in background. So for that, you need to go into capabilities, and in background modes, you need to select uses Bluetooth LE accessories. And this will add a line into your info plist, and the system will not kill your app while it's connected to any accessory. So at least the delegate methods of the CB Central Manager and CB peripherals can run in background. And you can, for example, schedule a notification. So I have in device view controller, and on the bottom I have a simple test. If the application is in background, I will create mutable notification. The notification will be different based on value. I will create a notification request, and I will schedule the notification. So let's try it. I'm going to connect to my Blinky and send the app to the background. And if I press the button, you can see that there is a notification not blinking anymore, and now blinking. So I guess we have reached our 2 hours. There is quite a lot more that can be told about core Bluetooth. I just showed you the simplest way how to interact with the thing, and I think this is going to be like the most common one, because you always need to connect to a device, you need to read some data from it, maybe listen for notifications, and then write any other data back. there might be other use cases. For example, you need to read bigger amounts of data, or you need to handle it on background more properly, even when the app is terminated. But this is a completely different story, and this code is kind of bit more difficult. Maybe last thing, if you are discovering characteristics, don't put nil here. I did it because I don't want to mess with another characteristics, but it's actually better to write all the UIDs in all speed, and this is the same with discover services, because if you put nil there, the system needs to actually probe the device in order to create those objects. But if you put the IDs of services and characteristics in the discovery methods, it will be way faster, and also the system doesn't need to actually probe the device, because it can have the characteristics already cached. So just try it, and you will find out that it's way faster when you are trying to discover something which has like much more characteristics and much more services. You kind of don't see the difference when you have like 2 services and 5 characteristics, but if you have a device with like 20 services and 50 characteristics, the difference is quite significant. Okay, so I guess that's it. So a quick recap. You can find the code here, and in master branch there is basically everything that we have written now. Remember the GATT profile, services, characteristics, and their descriptors and values. Is the link to core Bluetooth documentation. You can actually use core Bluetooth and you can turn your Mac into peripheral. So you can create the services, you can create descriptors, and then you will just stuff it into peripheral manager object, and it will create peripheral for you, and it will work exactly the same way as this blinky thing, for example. And the most basic class is CB Central Manager and CB Peripheral, which are your starting point for any bigger BLE stuff. So, thank you. That's all. Any questions before we get drunk?
I have one.
Yes.
Is there a reason you used manager, which you had referenced locally instead of the central provided in the function in the CB Central Manager delegate?
Can you point me to specific line, specific file, meeting manager?
Yes, here. You have in the function, you are provided with the central,
Oh,
and
yes.
you are using manager, which you have referenced in the class.
I see. These are equally same objects. The parameters here mainly because if you have more managers, you can distinguish which one is sending you these events. But it doesn't matter. You can
There is no
use
specific reason.
you can use any because they are identical.
Okay.
Yes.
Question about the local notification.
Uh-huh.
In the trigger parameter, I see nail.
Yes.
How it works? How the Bluetooth is connected to the notification center that it knows when to trigger?
If the trigger in the local notification is nil, it will trigger immediately. So there is no location trigger, there is no time trigger, calendar trigger. If you put nil here, it will trigger immediately. and this is basically a callback from device blink change. So when the device notifies the characteristic, I will schedule the local notification for immediate display. So instead of like toggling the switch, I will fire the notification only when the app is in background.
Got it. Thank you.
Any other questions? Okay, so thank you.